part 1 of electromagnetic induction moving the wire we will study. Number 1. Moving a single wire in a magnetic field. Number 2. The AC generator. Under the title of moving a single wire in a magnetic field, we will take a simple experiment and explanation. We will study how Fleming's right-hand rule is used to know the direction of the induced current produced. Then we will know how to get a stronger current by using the same apparatus or changing some of them. Then we will move to study the AC generator. First we will know the parts of the AC generator. Then the relationship between the AC generator and the AC current. We will answer 2 questions. Number 1. Why is it reversing current? Number 2. Why is it variable? After that we will draw the graph of the AC current produced from the AC generator. And finally we will know how to get a stronger current from the AC generator. In the experiment shown, we have a straight wire. The ends of the wire are connected to a galvanometer that will detect any passage of electric current. The wire is held between the 2 poles of a magnet. Now the wire is moved downwards by hands cutting the magnetic field lines. The observation is the passage of a small electric current that is detected by the galvanometer as its pointer is deflected to the right. Once the wire stops moving, the electric current also stops. Now if the wire is moved by hands upwards in the opposite direction, the galvanometer will detect an electric current, but this time in the opposite direction, as the pointer deflects to the left. If the wire is moved back and forth parallel to the magnetic field lines, no current is detected. Also, if the wire is placed inside the magnetic field but not moving at all, there will be no current. To explain what happened and how this current is produced from just moving the wire by hands inside the magnetic field, let's see this. These are the 2 poles of the magnet. The magnetic field lines, as we know, are directed out of the north and into the south. Now the wire moves between the poles and current flows. Scientists explain this natural phenomenon as follows. The reason is the metallic conductor wire cuts the magnetic field lines of the magnet, causing an induced current in the wire. Note that it's important to say induced current to describe the nature of this type of current. The rule that is used to know the direction of the induced current produced due to the motion of a wire cutting the magnetic field lines of the magnet is known as Fleming's right-hand rule. Even it is not as important as Fleming's left-hand rule of the electric motor, but there is still a chance to take place in an exam. If the first finger points to the direction of the magnetic field from north to south, and the thumb shows the direction of the motion of the wire, then the induced current will be produced in the direction shown by the right-hand second finger. This is the only way to know the direction of the induced current in the wire. A larger amount of induced current can be produced by some changes. Number 1. If these are the apparatus that we use, a horseshoe magnet, a wire, and a galvanometer or a milliammeter to detect the induced current, simply replacing a single turn wire with coil will produce larger current using the same magnet. Note that a coil with greater number of turnings will produce stronger current. Change number 2. Back to our main apparatus. Using a stronger magnet will help getting larger current using the same wire. So the second way will be use a stronger magnet. Change number 3. Back again to our main apparatus. If this is how the wire is moved cutting the magnetic field lines of the magnet, if we use the same wire and the same magnet, moving the wire faster will cause cutting to be with greater rate, and this also will cause a larger current. So we can say that the third way of increasing the amount of induced current is move the wire faster to increase the rate of cutting. So we can summarize the ways of getting larger induced current as follows. Number 1. Increase number of turnings of the wire. Number 2. Use a stronger magnet. Number 3. Move the wire faster, cutting magnetic field lines with higher rate. And we can add a fourth way, bring the poles closer.